Okay, so our topic today is Retina and iPad. We are attempting to demystify a little bit the additions that Apple made to their product line from 2007 and forward. This has a lot to do with existing technologies that we've already looked at, particularly automatic UI layout. But I wanted to go into the specifics of the devices that Apple offers and talk about what specific things that you need to pay attention to create high quality applications that work on multiple devices. More than just responsive UI or responsive layout. So it started like this. On the left-hand side should be represented the original iPhone that Apple put forward in 2007. On the right-hand side is an iPhone 4. The original iPhone had a very specific screen size. It was 320 pixels by 480 pixels. Tons, I know. That's like the resolution of my watch right now, but it is what it is. So what happened in later years, as Apple was coming up with new and better things to add to their lineup, is they decided to actually make a screen that has a reasonable dots per inch, a reasonable number of pixels per physical dimension. The previous phones were fairly powerful and did amazing things for what they were, but really their screens are pretty low resolution for the things that were being displayed on them. So this new resolution added more pixels, but the screen size was exactly the same. So essentially what happened was a single pixel on the original iPhone was the same as 4 pixels on the iPhone 4. And it's not 4 pixels wide, it's 4 pixels in a block. So 2 by 2. So the screen increased in resolution by 2x in each dimension. So the aspect ratio remained the same. The aspect ratio of the original iPhone screen and the iPhone 4 is 320 by 480, or 2/3. So an aspect ratio is a ratio. It is dimensionless. It is that magic number, 2/3. 0.66666 is the aspect ratio of the screen. So in order to support this change, mostly what people needed to do was utilize raster-based graphics and just draw with more pixels. So if you were defining all of your views as custom views and you were drawing all of your elements using DrawRect, or sorry, using the CG context in the DrawRect method of UI view, you just got more pixels and things looked nicer, period. That's just the way it worked. Unless you needed to actually draw a line that was exactly 1 pixel wide, things just got crisper. But there was an issue with images. You probably can't tell because the projectors used here, unfortunately, are not very high resolution. But the icon on the left, at the top right corner of the screen, is half the resolution of the icon on the right. And there's a marked difference between the two when you look at them on a screen with a higher resolution. So you have to deal with raster graphics. Most user interface elements, including the ones that I was showing in this example here in the old style UI, are defined in some mathematic way. You're using a gradient, or you're using a shadow, or something like that. But some of them, specifically the icons, are image assets. Those are not defined in a math way. They're not defined as a raster graphic, a graphic that is made using a system that tells how to draw the graphic rather than saying the individual pixels that the graphic is made of. So when you use raster graphics, or graphics that are made up of pixels, you need to have another version of the graphic. So these were called at2x images. The reason why they were called at2x was because if you had an image named icon.png and you wanted to have a version of that icon that was displayed on Retina screens at a greater size, you just called it icon at2x.png. And the UI image class would automatically find the appropriately named image when you called UI image named. These were later added to what are called assets categories. It's a folder with a specific construction and a plist file inside that organizes these icons together such that you don't have to worry about this at2x extension if you use the asset catalog. But you don't have to use asset catalogs. The at2x thing still works. And quite frankly, it worked pretty well. You just had 2 versions of all of your images, and one was twice the number of pixels as the other in each dimension. They're supposed to contain the same content, but that's a misnomer just by virtue of what I just said. You can't have an image that is twice the size of another image that has exactly the same content. You look at the pixels, you look at the actual files, and they don't have the same stuff. So it's a visual thing. They should visually have the same content. The human eye should perceive them as having the same structure. It doesn't seem like a difficult distinction, but it kind of is, actually. One of the important things about creating icons that are twice the size or twice the number of pixels as the original is you can't just upscale them. We've all seen that when people upscale things on advertisements or wherever where they're trying to use an image that just doesn't have enough pixels for the output device, whether that be a pixel or a screen or what have you. It's pixelated. It gets lots of blocks inside. But you have the inverse problem as well. If you take an image that is 10,000 pixels by 10,000 pixels and reduce it to an image that is 100 pixels by 100 pixels, you'll get mimification effects rather than magnification effects. The mimification effects will exhibit themselves as lines and curves that just instantly disappear, or strange aliasing and jagginess and ringing that occurs in patterns in the images. So what you have to do is you need to go to the original format that was used to actually create the image. Whether that was a software program like Adobe Photoshop or Illustrator or some other vector-based drawing program, or if it was some physical thing that utilized scanning in order to create that image, you need to go to the original image source and re-export the images at a different resolution, a different image size, such that there were more pixels. These images are shown at the same physical size on the 2 different devices. On a device that is regular sized versus a device that is Retina, the physical representation of the image should be the same. And the way that that's done is using what's called a content scaling factor. Every UI view has a content scaling factor. It is a float that on the original iPhone didn't exist, but when they updated the API, the float was 1.0. On Retina devices, that float was 2. So you knew what kind of content was being displayed at the view level. Those views obtained that information from whatever screen they were being presented on, because you can actually hook an iPhone up to a TV, and that changes its content depending on whether or not you're doing mirroring or it's actually acting as a separate external display. So that's how that understanding of content scaling works. I've used the term Retina several times up to this point. This marketing term was coined during the time that Steve Jobs was still with us. And he explained it as the fact that the human eye can't distinguish even more pixels on a screen at a regular viewing distance, which they define to be something arbitrary like 12 inches or 14 inches, so holding it in front of your face like this. So some of you may have 4K TVs. Does anybody have an 8K TV? They've made them. Why do you think they're not particularly popular? Number one, because there's no content for them. But people play video games. You can render video games at whatever resolution you want. That's because they're raster graphics. But why isn't there a big deal about 8K?
Because you already can't tell the difference between HD and 4K.
Because you can barely tell the difference between HD and 4K when you're sitting on the couch and the TV is, 20 feet in front of you, right? Or whatever it is. Yeah, if I'm like playing my original Nintendo Classic that only has a cable that's this long and it's right in front of me, it's gonna matter. But most TVs are not displayed that way. The use case for a TV has an expected viewing distance. And so that's what Retina was all about. The idea, though people will argue as to whether or not it was true, The idea was that if we were to add more pixels, it wouldn't actually make the image any better. And that, as an idea, is actually a pretty good one. We should be trying to create devices that use screen resolutions that at their expected viewing distances are as good as they can be, according to the average human. There are superhumans that can still tell the difference. And you also don't save the average human over their entire lifespan, because eyes get worse as age goes up. They are correlated. So pay attention to that as well. That's what Retina means. That's the intention. Make fun of Steve Jobs if you want. I still think it's a great idea. Every device should have that. So this leads us to talking about coordinate systems. If you have two screens that are the same physical size, is there a way that you can make it such that the software running on each screen can go without modification as long as you're not using raster graphics? What Apple did was define the points coordinate system. We talked about this previously, but I'll go over it again. We'll talk about it quite a bit. Apple defined an arbitrary coordinate system called points. And one point corresponded to one pixel on the original iPhone. This idea of points is actually predates the iPhone. It was a coordinate system available on macOS 10 as well. So they were somewhat consistent about it. But 1 point was 1 pixel on the original iPhone. So a screen is 320 points tall by 480 points, 480 points tall by 320 points wide. But when we move to a Retina screen, it still is 320 points wide, but it's 640 pixels wide. So you multiply by the content scaling factor. That's what the content scaling factor is for converting from the points coordinate system to the pixels coordinate system and vice versa. If you take a width of anything and you multiply it by the content scaling factor, that will take you from the points coordinate system to the pixels coordinate system. By dividing, you can take some calculation that you already performed in pixels and convert it to the points coordinate system. So that's a width, a height, or a XY location. Fairly straightforward. Hopefully everybody already knew that, but wanted to just state it again. So Apple had kind of an upgrade process where you could take an application that was written for the 320 by 480 phone, because that was the only screen size that they had for several generations. And they said, okay, to update to the new screen size, you could just do nothing. And what you get is high-res standard controls. So these standard controls that are the old version and look better than the version that they're putting forth now, but that's personal opinion, happen for free. All the gradients involved would be automatically calculated because they're raster graphics. This is still true, even with the newer, less good-looking standard controls that Apple is now proposing. They just have less pixels involved with them. But where they do exhibit having some actual content to their standard controls, that content is drawn such that it takes advantage of the screen automatically. So you do get those standard controls for free, but for everything else, you need to pay attention to it. In your own drawing with DrawRect and UI View, you should get just crisper versions of whatever you drew, but depending on what you are drawing and what your goal is, you may need to modify your code to take advantage of the content scaling factor, to multiply back and forth to convert from points to pixels. Also, there is an issue with the points coordinate system in that it does not correspond to a physical sizing. Apple tries to make this true, but they haven't stayed consistent with it. On Android, however, their corresponding technology, which is referred to as DP, device-independent pixels, is a physical measure. They came up with it in a very similar way. They had a popular screen size at the time that they were defining these things, I believe with Android 2. It might have been Android 1. I'd have to check my history. But there was the G1 phone. The G1 phone had a 160 dot per inch screen on it. So if you measured that screen with a ruler, 1 inch of that would have 160 pixels under that ruler segment. So this desk, I can find out how wide it is in DP. So take the width of this desk in inches and multiply by 160. That's how wide it is in dp. So dp is a physical measure. I can say how tall I am in dp. Points, however, don't exhibit that. Apple's never said a point corresponds to this physical size. They have said a point generally corresponds to this physical size in several places, but they never actually make the guarantee. Unfortunately, even on Android, the hardware manufacturer gets to say how big their screen is from a software point of view, so they can still lie, which is unfortunate. And there's so many Android devices out there made by extremely varying qualities of hardware manufacturers, so you will run into devices that report their screen sizes wrong, unfortunately. So you can't use your Android phone's screen as a ruler in general. Why does this matter? Because users' fingers don't change in size when they buy different phones. It's usually not as much about how much you can see. It's about how big that is in terms of user interaction. And that has to do with the finger, the pad of your finger, how large the pad of your finger is. My grandfather has huge fingers, and he has a hard time using even a regular keyboard. He had to buy a special keyboard that was bigger. The keys are comically large. It's a big deal. Kids have very, very small fingers. And applications made for kids, strangely enough, have really, really large user interface elements, even though they have smaller fingers, because they're kids. They want big, chunky controls. But pay attention to the size of your own finger. It's probably average-ish. This is the law of averages, but that will help you to know what other people's use cases are going to be. And that is the thing you want to pay attention to in that case. So use the points coordinate system and try to make it correspond to physical sizings of elements on the screen. This is more important for iPad, which we'll talk about a little bit more later. So why don't we just standardize on At2X, because there are no non-Retina screens left, right? This is an old image, but still true. No, there are definitely current generation devices that have the standard resolution. Particularly they are iPads. iPads have a lot longer lifetime than phones do. You will not ever find anyone who is still using the original iPhone. I would love to see somebody do that. It would be great. But you will find people using the original iPad. It's out of service from operating system point of view, and Apple doesn't support it anymore. But there are several newer generations, including the original iPad mini, which is still getting used. So this is still current technology. You do have to pay attention to At1X screens. And there's another reason now, because there's such a thing as an At3X screen. So we'll get there in a minute. But right around the iPhone 5 time, Apple threw another curveball at us. Everyone was talking about HDTV, and HDTV had mostly been rolled out across the United States and other places in the world. I know this is around like 2010, but a lot of people still had standard definition TVs. You may not remember. But for some reason, this aspect ratio 16:9 became a big deal. It's arbitrary that the screen size of a TV is 16 units wide by 9 units tall, but that's what everybody standardized on. There's been a lot of research that says that a wider version of that is actually better. You'll find many movie directors that get mad that 16:9 was chosen as the standard size. Causes them no end of trouble. But it is what it is, and it's unlikely to change, at least for a little while. So Apple created a 16:9 phone. But they had a problem. They couldn't use 320 points by 640 points anymore because the screen changed in aspect ratio. It's no longer 2:3, it is now 9:16. So it actually became taller. It's 1,137 pixels, or 568 points. So the screen size changed stayed about the same, but the aspect ratio changed, and 2/3 is not the same as 9/16. And so you've got this extra space. There's actually a bunch of parodies about this when Apple was touting this new device that was longer. There were a bunch of Android phones that had made this switch a long time before, finally, quote unquote, caught up. But the parody videos were this guy walking around with this amazingly tall screen. It was like 540% taller. It was as long as his leg. He put it into a pocket that went all the way down to his knee. It was really great. You should look it up. But that was the issue. It was longer. So let's say that you wrote an application for the 320 by 480 screen size that Apple had been using for almost a 5-year period. How do you take advantage of this new screen? What modifications would you make to your code? I know there's only 4 of you guys in this particular section, so you're going to have to come speak up. How do you modify your layouts? Just with stuff that you've done so far in class. There's not one answer here, so.
You just do this stupid way and have everything stretch a little bit to fit the new screen.
You could have everything stretch a little bit. If you literally stretch it, then like letters get taller and those kinds of things. That's not going to work. I mean, nobody will take that. Yeah. You can do letterboxing. Remember how we had the blank bars at the top and bottom? Apps were actually kind of like that for a little while. People rapidly updated their applications because those black bars consumers really hated. Whereas on iPad, do you remember how on iPad you could push the 1x, 2x button to make the iPad just show a regular size screen at a larger size, and they just put black bars along the edges? You can still do that. Actually, if you deploy an iPhone app that is only built for phones to an iPad, there will be a 1x, 2x button that you can push that just blows the screen up or reduces it. So guess what? 2x3 still exists on iPad right now, the newest one that I can go buy at the Apple Store today. What else can we do? We can just change our layout, right? Just put more stuff in there. You know, maybe there's something that you didn't display that now you can display because you've got a little bit more space. Or the more likely situation, what if your layout already scrolls? Think about iPhone applications that you use every day. How many of them scroll vertically? Most of them, I would say. So this wasn't a problem for many people. They just increased the size and it just worked. They basically pulled down the new version of the development tools, built their app, looked at it and said, yep, looks good, and then moved on. So it depended on the app, but probably a third of people were caught flat-footed and they had to actually do something. Or they just did nothing and had like empty space somewhere in their interface, and then you knew which apps were high quality and which ones weren't. So that was nice. So the changes in dots per inch don't affect you as much as changes in aspect ratio. Those are actually the things that cause you trouble because it's changing the nature of the screen. I have this dimensionless number that tells me that this screen is different in nature than this other one. So that modifies what you're showing. So with aspect ratio, there are things that we can do like we just described, but one of the things that is pretty interesting is how aspect ratio affects games. It actually affects gameplay. Is anybody in here an Overwatch fan? Play tons of Overwatch? Or some other first-person shooter, maybe you're a CSGO guy, whatever it is. Have you ever run into people that just seem to be able to look around corners really well? No? Yes? Maybe? Depends on which game you play. It's because they'll stack it, put a screen in front of them, and then they'll put a screen on the right of that, and on the left of that, and some of them might even then put another screen on the left of that and on the right of that. And then they get like this 180-degree view where they can see more. right? Because it's an aspect ratio change. You can't just like stretch out the guy's point of view. That makes everybody look really squatty. They're all dwarfs, right? You can't do it. You have to do something. You have to fill it with content. So it's solved in one of two ways. Either it zooms in and the guy becomes a sniper, or you get a larger field of view and the guy can look around corners better than everybody else, essentially. Not around corners, but can see more space such that you can be hiding over in this little section of the screen. One person would not be able to see you. This person would. This affects gameplay, right? If you're trying to be competitive in a situation like this, you will choose a number of screens to be able to be better at the game. So, and this is not solvable. This isn't just like, oh, hey, we haven't figured out a way to do it. It has to be that way because of the output device. So it can affect rules of games. So here's an example of how it affected a two-dimensional game that I built. This is a game called Jazzball. It's kind of stupid. It's a field that has these small balls that are bouncing around on it. And when you tap the screen, it creates two wall makers. They emanate to the either left or right or up and down. And when they reach the edges of the field, they disappear and it cuts the field at that location. If the balls run into the wall makers while the wall makers are moving, before they get to the edges, you lose lives and you die. It has no physical analog that I know of. I don't know what the guy was smoking that made it originally. When I was a kid, Windows 95 Plus Pack came with Jazzball, and I played it. I liked the game, so I remade it. And you can still get it today. Feel free to play it. Actually, I think I charge you for it, so I don't know. If you want to play mine, feel free. It's like 99 cents, though, seriously. The issue that I ran into here was Jazzball has actually been out on the App Store since like the very beginning. It was one of the first 300 apps that came out on the App Store. I actually had 1% of all apps on the store were written by me at one point. It's really pretty fun. But when iPhone 5 came out, I had to update Jazzball. So if you probably can't see very well, but on the left-hand image, the balls are not circular. They are elongated. They're an ellipse. And the characters at the top that make up the UI are slightly stretched. Does that really matter? Actually, it got very distracting because there's a square grid in the background. If you just pay attention to the grid, you can pretty easily see that on the left-hand side, those are stretched rectangles, whereas the one next to it is squares. See that, the gray grid? You don't see it right off, which is really helpful to me, but I still wanted to fix the problem because eventually you figure that out. And it gets worse on other screens, particularly when I ported this to Mac. So by changing my OpenGL view to take advantage of the fact that this is now an iPhone 5 screen, letting it know that, hey, you are allowed to be 568 points tall instead of 480 points tall, I ended up with this. But that affected gameplay because the way this game actually works is you win a level when only 1/4 of the gray is left. So you have to cover three-fourths of the field. So because it was percentage-based, I could actually just add more cells to the field. And that worked from a gameplay perspective. It didn't waste all of that space. So I didn't have the look around the corner problem here, but I still had to solve the problem. The size of the field on an iPhone 5 is different than the size of the field on an iPhone 4. It actually has a different number of cells. The actual array that I use for doing the logic on the game changes in size. So this necessitated a data model change, not just a visual change. So aspect ratio will bite you. So pay attention to it. This got more complicated as time went on. We got iPhone 6 and iPhone 7 days, and not only did we have iPhone 6 and iPhone 7, we also had the Plus version, which is great. When I first bought this, people thought I was crazy because I had this mega huge phone. Now it seems kind of average. Strange how that happened. Cell phones got smaller, then they got bigger. But if you look at the rundown here, the iPhone 6 and the iPhone 7 and their Plus variants actually are about the same in terms of pixel sizes. 1334 by 750, 1920 by 1080. I wonder why they chose that pixel size. At different resolutions. The only real difference on iPhone 7 is the color gamut. It actually uses a wide color display rather than full sRGB. And that's because they got that new camera on it that does deep colors. And uses more than 8 bits for a color channel. So things will look really vibrant on an iPhone 7 versus an iPhone 6 if images were captured for that using a high dynamic range camera or some other high dynamic range image format or drawing or whatever. So that was the main difference there. Most people probably won't ever notice and won't ever care. But it does cause trouble for us because it adds @3x. I ripped this off from the paint code people, so I need to give them proper attribution. I took this from their website. This is not mine. I did not make it. So I'm going to give you a little pitch for them so they won't sue me. Paint code is actually pretty cool. I really do want to give a pitch about it because what paint code does is it's kind of sort of like Illustrator. You draw something using vector graphics, and they can export to SVG. I think they can export to some of the Adobe formats, or they can export to Swift. And it will write Swift code that you can copy and paste into the draw view of your custom view, and it draws the thing. So they have a code output. That's why it's called paint code. It's pretty great. So look into their product. It's $99. Well worth the money if you own a company. Still might be well worth the money even if you're just building apps for yourself. But what they've done here is they have broken down all the different screen sizes for iPhones. I wish they had an iPad version of this, but they don't. And there's an interesting thing that happens. When iPhone 6 Plus and iPhone 7 Plus come along, they are 375 by 667 points, but when they're rendered at 3x. So there are 9 pixels that correspond to every 1 pixel. However, that's not the actual size of the physical display for these devices. The iPhone 7 Plus, for example, is actually a 1080 by 920 screen, even though 414 times 3 is 1242. So they actually downsample. They render at a larger size in memory and downsample when they actually display. So if you want to draw a 1 pixel wide line on an iPhone 7 Plus, it's actually kind of hard. You have to draw a line that is 1.15 pixels wide, and you have to do the calculation for pixels, draw it, and then have it downsampled properly. So at this point, just nobody does it, which is too bad because crisp graphics are great. This also happens on the non-Plus versions. It does downsample to 0.96, but only when you're using a particular mode. If you bought an iPhone 6 or an iPhone 7, during the setup process, or at least for the Plus version, you are asked, do you want the zoomed mode or do you want the regular mode? The zoomed mode actually is a different downsampling. They change the number of points that are in that sizing. So on iPhone 7 Plus, the screen is 414 points wide if it's in the regular mode. It's in 375 points wide if it's in zoom mode. And you say, well, nobody chooses the zoom mode. I'll just not worry about it. Actually, a lot of people choose the zoom mode, those that are 40 plus. Apple found that there was a very large market for people that just wanted to have a really large screen phone but didn't want to have more stuff on there. They just wanted everything to be a little bigger. So tons of people use this mechanism. And a lot of them are ones that have money because, you know, they're older. So you want their money. You want your software to be used by them. So pay attention to them. This is a slanted scale. So this image is great because it actually demystifies all of that and tells you for every single physical device what the physical screen size is, what the point size for the screen is, how it's rendered at 1x, 2x, or 3x, and how the downsampling works, should you care. So pretty great. Questions on this? other than what on earth were they thinking? Because I don't know the answer to that question. Cool. It's actually kind of hard to get this information all in one place. I really wanted to draw attention to the fact that it's here. So another issue that I ran into with iPad was the aspect ratio issue again with Jezbal. Now, things are kind of comically large. That's okay. Still works. I could make things be smaller and just have a larger field. But I ran into the same problem. Everything looks kind of fat because now the aspect ratio is pushed in the other direction. You probably can't even tell on the projector. Maybe if you look at the gray background, you can see that these are slightly fatter than the gray cells on the right-hand side. But you can solve that problem in the same way, again, by changing the number of cells. On Mac, definitely had to pay attention to this because that changes by aspect ratio a lot. And actually here on the Mac, I have to say the window size needs to be of a particular aspect ratio. Because if they change the window size while they're playing, I can't change the size of the field. Maybe I could, I don't know. But that would be a huge change to the architecture of the game. So they are able to size the window to different sizes, but it's locked to a particular aspect ratio. If they go into full screen mode, it gives them bars on the sides or at the top. And this is just a dumb little game. You know, you guys are going to run into bigger problems with the more complicated apps that you're going to be defining. So this is really a problem. This is something that you need to solve. The aspect ratio changes will affect the quality, the perceived quality of your user interface if you don't actually respond to them well. They'll be chunky, they'll be odd, they'll be stretched, they'll be sparse, depending on how you solve the problem. So just try not to assume screen sizes as much as you possibly can. iPad is popular. You'll find it all over the place. Its resolution is very different. The biggest difference with it, however, is size. So you need to pay attention to the physical sizing of elements on iPad. Points somewhat correspond to physical size. Not as well as I would like. So do pay attention to that physical sizing constraint and the aspect ratio constraints. One way that you can work with iPad in a fairly good way is to use user interface elements that are optimized for taking phone-style UIs and making them work on iPad. The main one is split view. So split view allows you to show two view controllers content at the same time. You can have the master view on the left and the detail view on the right is what they're referred to as. And so split view is a container view controller that has an array that takes exactly two elements. The first is the master, the second is the detail. You can embed navigation controllers inside of those, or tab bar controllers inside of those, and then embed content inside of those. What's really nice is that the master is always 320 points wide. They did that to make that an easy transition. So there were existing user interfaces, say a mail application where you have a list of mail messages and then the detail content for an actual mail message. On iPad, you just show both of those view controllers at the same time. And if you wrote your code in a fairly agnostic way that you could show both of those views at the same time, it was very easy to make this transition. And I think that's one of the reasons why iPad got acceptance so quickly from developers. Personally, I still don't understand why iPad is popular as a device. I've tried several times to buy and own and use an iPad, and I just never do. And I suspect it's because I own one of these, and I own one of these. Which, you guys are in that boat too, mostly. You own a laptop, and you own a phone, more than likely. You probably don't own a tablet. But if you ask the population at large, you will find a very large segment of them own a phone and a tablet and not a laptop. So pay attention to that market. Just because they're not you doesn't mean they don't have money. Sorry, that's a little facetious. Some people do want to just build software as open source, but they're a user base, and there are a lot of them. You can also use things like the popover controller, which is really great. It uses that same idea of 320 points wide, but a different sizing, and you can still have additional content on the outside. Context menus, which are available on more than just iPad as well. And modal presentation. So you can show a little bit of context behind a modal display, so a view controller that is presenting another view controller, but you can use a different presentation mechanism to have it take on one of these different shapes. So iPad takes a little bit more work, but because it's a larger screen, you can do more with it. There are quite a few applications that are iPad exclusives because they just plain don't work on a smaller phone. But they do work on an iPad. So, look at that as an interesting development opportunity. So I was going to do a practical for you guys today and show how 1x, 2x, and 3x images work and start talking about the finer points of this. But you won't be able to see any of it because the projector just doesn't let it happen. And so you would have to all crowd around my laptop or something like that. So we're just going to dispense with it. Go ahead and try it yourself. Get some physical devices, use 1x, 2x, and 3x images inside of an image view and just a very easy test app, and you will see the difference rather rapidly. You may have used a low-quality application that didn't have proper image assets as well, and you can see the difference that it makes. So it's not something that people point to immediately and say, oh, I'm not going to buy that thing because it's not using image assets. What they're going to do is they're going to have this underlying perception that what you've created is low quality, but they can't put their finger on why. So do it. It's important. That's what I've got for you today. So this is our second to last lecture. Our last lecture is going to be on Monday. It is the day before the semester length classes end. And you guys have a reading day, and then you start working on finals. So we'll see you next time.